Good morning students. In this session I am going to start a new chapter, that is thermodynamics. Let's we discuss what is thermodynamics at first. Let's see what is thermodynamics. So students, let's see what is the word thermodynamics means. The word therm means the word therm means heat, and dynamic means motion or movement of heat, motion or movement. The word therm means heat and the dynamic means motion or movement. In fact, we can say that the motion of heat we will study in this chapter. So what is thermodynamics, students? The branch of chemistry which deals with the movement of heat and the factors affecting them. So this is called the thermodynamics. Let's discuss some basic terms of thermodynamics. So our next topic is some basic terms of thermodynamics. So at first we study about the basic terms, students. At first, what is systems and surroundings? So try to understand at first. The universe divided into two parts, that is called the system and called surrounding, and in between this is called the boundary. So let's discuss at first what is system. So write down the definition of the system. What is system, student? So system is that part of universe. System is that part of the universe in which the thermodynamic changes have been studied, thermodynamic changes have been studied. So at first we have a clear concept idea about the system. What is system? System is that part of the universe in which the thermodynamic changes have been studied. Let's discuss what is surrounding. Next term is surroundings. The part of the universe except system is called surrounding. Suppose, students, we will discuss about this particular things. So this is for us it is the system, and except this all other thing is called the surroundings. So next one is the boundary. What is boundary? The part of the universe except the part of the universe that boundary is that part which separates system from surroundings. Systems from surroundings. So in this way we can easily understand what is system, what is surroundings, and what is boundary. Boundary may or may not be definite. May or may not be definite. Defining. So students, next we discuss, according to boundary there are 3 types of systems. So let's we discuss. There are 3 types of system. First, we call it open system. Second, we call closed system. And third one is called isolated system. Isolated system. So let's we discuss about at first the open system. What is open system? So at first, open system. Open systems are those systems in which the exchange of mass as well as the exchange of heat is possible between system and surroundings. Between system and surroundings. In open system there is no definite boundary. Means mass is not constant and heat energy is also not constant. So students, here we use Q symbol for heat. So there is not the mass is constant, not the heat energy is constant in the open system. For example, suppose we have tea in a cup. Suppose we have tea in a cup. So tea in a cup, and there is not the mass constant, not the heat constant. So it is the best example for the open system. We talk about in details further in next topic. So in open system, there are those systems in which exchange of mass as well as exchange of heat is possible between systems and surroundings. This is called the system, and apart from this, all are the surroundings, and there is no definite boundary. So in this way, we can say that those type of system in which not mass and not heat is constant. So this type of system is known as open system. Next we discuss about the closed system. Closed system. It is a system which can exchange energy, but not matter, T in a closed bottle. Suppose example, T in a closed bottle. So if T is keeping closed bottle, that means there is only exchange of energy takes place, not the exchange of matter takes place. This type of system is considered for the closed system. For this, mass is constant, but heat energy is not constant. Next we talk about So students, there is a heat energy exchange between systems and surrounding. So students, in closed system, the boundary is definite. We can say that because T is in a closed bottle. So there is, suppose there is a closed bottle and inside there is a heat. So there is a boundary between the system. T is a system, and apart from the system, all is the surrounding. So there is a boundary. So we can say that in closed system, the boundary is definite, but the boundary is conductor of heat also. Boundary is conductor of heat also. For isolated system, next one is isolated system. It is a system which cannot exchange matter and heat energy with the surroundings For example, tea in thermos flask. Both matter and energy of the system are neither lost or gained, in which mass is constant as well as heat energy is always constant. So students, these systems are those systems in which neither mass nor heat can be exchanged between systems and surrounding. So because in this system it is also called, we can say that the boundary is adiabatic. The boundary is isolated system, that is called the adiabatic boundary, because boundary is isolated for the heat. So in fact perfectly isolated system is not observed. So recall it, we have discussed three types of system: open system, closed system and isolated system. So students, what is system, what is surrounding, and types of boundary, what is boundary, types of boundary. So let's we discuss the next topic. Thermodynamic properties. Thermodynamic properties. Thermodynamic properties are those properties which tell how the nature of the system. Simply, tell us about the nature of the system. These are following are the thermodynamic properties. For example, if we talk about the density, heat capacity, pressure, volume, temperature, conductivity, EMF of the cell, specific heat, viscosity, surface tension, refractive index, molar heat, etc. So it is further classified into two parts. So it is further classified into two ways. Thermodynamic properties classified into two ways. The first one is intensive property, and second one is extensive properties. So what is intensive property? Those property which is independent of mass, means those properties which do not depend on mass, independent of mass, is called the intensive property, and which depends on the mass is called the extensive property. For example, volume does not depend on the quantity, boiling point, for example, or in other words we can write in this form also, value does not depend on the quantity taken. Whatever the quantity we will take, the value does not depend on this particular quantity, like boiling point, like melting point, and temperature, density, or there are so many extensive properties are there. Remember it, and in which value depend upon the quantity taken is known as extensive property, like volume, mass, heat capacity, so many change, enthalpy, entropy, internal energy, enthalpy, change in energy, all are the extensive property, and classify them which one is a extensive and which one will be intensive property. So students, it is for assignment for you. Classify all this property into the intensive or extensive properties. So let's discuss the next property. That is the thermodynamics variables. Thermodynamic variables. What do you mean by the term thermodynamic variables? Thermodynamic variables are those variables by the means of which we can define the thermodynamics state of the system, either is solid or liquid or gas. So student, thermodynamic variables by which we can classify the thermodynamic state. So let's discuss. There are three variables. Note down mostly we discuss about the three variables in states of matter also. Three variables, that is called the pressure and temperature and volume. So these are the three variables we use for the knowing the states of thermodynamic state of the system, by which we can find the state or phase of thermodynamics of any system. So suppose we have 10 gram water. By 10 gram water, we can't predict it is the solid state, liquid state or gas state or vapor state. But if conditions are given by this variable, suppose pressure is given 1 atm, volume is given suppose 10 ml and temperature is given suppose 25 degree Celsius. So simply we can predict at 25 degree Celsius the phase will be obviously liquid state. For 10 gram water, second condition, suppose pressure is again 1 atm, volume is 10 liter and temperature becomes 150 degrees Celsius. What will be the phases of particular this thermodynamic state? So students, by knowing this particular variables, we can easily predict this is the steam phase or gaseous phase or vapor phase, vapor or gaseous phase of water. Next condition, if given, suppose we have again pressure is 1 atm and volume is suppose given 10 ml and temperature is given minus 20 degrees Celsius. So you can easily predict what is the phase. Simply this is the solid phase, I is in the form of solid. So these are the variables by which we can find the state or phase of thermodynamics of any system. Suppose we have pressure given is 1 atm and volume given is 10 liter, suppose given is 10 liter and temperature is suppose given as a 25 degrees Celsius. So 10 liter or temperature given to 25 degrees Celsius. So we can predict at this temperature water exists in a vapor form. So these are the variables by which we can find the state or phase of thermodynamics of any system. Next we discuss the thermodynamic quantity. Thermodynamic quantities. Those quantities which depends upon thermodynamics variable, thermodynamic variables like pressure, temperature, volume are called thermodynamic quantities, thermodynamic quantities. So there is a 4 thermodynamic quantities we will discuss later on. 4 thermodynamics quantities. These are number 1, internal energy, we symbolize by E or U. Next one is enthalpy. Enthalpy we symbolize by H. Number 3 is entropy. Entropy symbolized by S. And number 4 is Gibbs energy and it is symbolized by G. So students, what is thermodynamic quantity? Those quantity which depends upon thermodynamics variable. This are the quantities which depends on the variables, pressure, temperature, volume. So this is called the thermodynamic quantities. So next we will discuss in the next video. So that's enough for today. Try to understand, do revise.